Alright, today we are going to start our next lesson where we are going to learn how to graph something called piecewise functions, and we're going to begin talking about, we're going to graph step functions, and we're going to begin talking about piecewise functions, which we will finish in the next lesson. So first, for the do now, let's explain what is different about an absolute value function and a linear function. An absolute value function has these lines with the x in between them. A linear function will just have a plain x. So, absolute value functions look like a v, a perfect v, where linear functions will look like a straight line diagonally, or maybe it's one that's going down, or it could be horizontal, or it could be vertical. Those are some differences. And some things that are the same are they're both functions. So those are just some things. So today we're going to learn how to evaluate and graph step functions, and then we'll also start working with piecewise functions. So what is a step function? Step functions are functions that change after certain x values. These are basically a type of piecewise function. There's different pieces, and you're going to graph each piece depending on what interval for x they want you to use, what domain they want you to use. So like, for example, they first told you to start out using 4 when you go from 0 to 1. And then they told you to use 5 when you go from 1 to 2. And they tell you if you should use an open circle or a closed circle depending on your inequality symbol. So let's look at this first one. Graph the following step function. All right. First, they're telling us that 10 is from 0 to 4. Okay. So 10, 10, 10, 10. At 4, we're going to have two different numbers, so I'm going to only use half of it. So at 0, because it's a less than or equal to symbol, it will be a closed circle. And at 4, because it's just a less than symbol, it will be an open circle. So let's go graph this. Let's go to 0, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then 110, 210, 310, and at 410, we're going to use an open circle. I'm going to connect these, and I'm not going to put any arrows because they told me where to start and stop. Okay, then the next one. We have 7 from 4 to 8. But at 8, we're going to have two different numbers, so I'm just going to put it halfway. At 4, we have a closed circle because they used a less than or equal to symbol. At 8, we have an open circle because they only used a less than symbol. Perfect. And now let's look at this last one. We're 4 from 8 to 12. We are going to be a closed circle at 4 and a closed circle at 12 because both for 8 and 12, we use less than or equal to symbols. So let's go graph the first one. 7 at 4. And that's a closed circle, closed, closed. But then at 8, 7, we're going to use an open circle. And then at 8, 4, 1, 2, 3, 4, we're going to use a closed circle. 9, 4, 10, 4, 11, 4, and 12, 4. And we connect these both. We do not use any arrows because they tell us where to start and stop. And this is what it looks like. This is a step function. The only points that are real points are the shaded in circles. And this is a function because if you use the vertical line test, each vertical line will only cross through once. Even though if you put a vertical line at 4 or 8, it might seem like it's crossing through twice. We do not count the open circle. All right, let's look at this next question. Evaluate the following function. All right, here they're telling me that x equals 0. So I need to find out if that means 0 is between 0 and 5, not including 5, or is it in between 5 and 10, including both those numbers. 0 would be in between 0 and 5, and my answer would be 2. 2 is in between 0 and 5, my answer is 2. 4 is in between 0 and 5, my answer is 2. 5 is not in between 0 and 5 because the 5 is not included. But 5 is in between the 5 and 10 since the 5 is included. So that would be 6. 7 is in between 5 and 10, so it's 6. And 10 is in between 5 and 10 since the 10 was included, so that is 6. That is how we could evaluate a piecewise function. Let's look at another example. All right, we are going to graph this. So we are from 0 to 5. So from 0 to 5, our y value is 2. At 0, we use a closed circle since it's the less than or equal to symbol. At 5, we use an open circle since it's only a less than symbol. So let's go 0 up to 2. 1, 2, 3, 2, 2, 3, 2, 4, 2, 5, 2, but with an open circle. And this other one, from when our x values are 5, 6, 7, 8, 9, or 10, our y values are all 6. All right, so 5 up to 6, 2, 3, 4, 5, 6. And they're both closed circles since they are less than or equal to symbols. And let's connect the points. And that is our final step function. Nice job. Alrighty, let's get started on this real-world example. A local amusement park charges an admission based on age. Graph the amount of money a person would have to pay for admission based on their age. Remember that someone who is 1 day shy of 4 years old can consider themselves 3 and under. So unless it is literally your 4th birthday, you are still 3 because you are 3 in however many months. So it's telling us that whenever you are 3 and under, you are free. So that means up until the day you are 4, up to 4, you are $0. Okay, so we're $0 when we're 0. We're $0 when we're 1. We're $0 when we're 2. When we're 3. And up until 4, we're $0. But at 4, we're no longer $0, so we're going to put an open circle there. All right, let's look at this next one. 8 and under. So from the age that you are 4 up until you are almost 9, you are going to equal $4. At 4, you are definitely $4, so that would be a closed circle. But up until 9, not at 9, you're not $4. Only up until you're very, very close to being 9 are you $4, so that's an open circle. So at 4, let's go up to $4 and put our closed circle. At 5, 6, 7, I meant to put, 8. And at 9, it's an open circle, because at 9, you're going to be the next category where you're $8, but when you're 8 days and 300 days, you're very, very close to being 9, but you're not exactly 9, so we put an open circle there. All right. From when you are 9 up until when you are 16, you are going to pay $8. Since 8 and under is definitely 4, that means 9 is definitely 8, so that's a closed circle. But I meant to put 17 here, because when you are 16 and some odd days, you are almost 17, but not quite, so that's an open circle. All right. So at 9, we're $8, 10, 11, 12, 13, 14, 15, 16. But sometimes you could be a little bit more than 16, but not 17 yet, so we put an open circle. And then 17 and older is $12. So let me first connect these points. So that means anybody 17 and older, all the way until you're whatever age, you're going to be $12. So that means that everybody 17, so 17, 15, 16, I didn't go enough points. I think I need to do one more. Let me count. 10, 11, 12, 13, 14, 15, 16. Oh, I need to do one more. 17 with the open circle. Okay. All right. When you are 17 and older, you are $12. At 17, you're definitely $12. 18, you're 12. And then so on. Anybody over the age of 17 is going to be that $12. And that is what that function would look like. All right. Let's look at this second real-world example. The postage rate on an envelope is a great example of a step function. There is a fixed price for a certain range of weights and then another fixed price for another range of weights, meaning that if the envelope is in between 0 and a half a pound, it's one price, then half a pound to 1 pound is another price, and so on and so forth. Below is the graph of such a structure. So here they're showing us what the weights are. And then for different intervals, we have different prices, the postage charge in dollars. So based on the graph, what would be the postage rate on weighing 1.5 ounces? Meaning that x equals 1.5. Let's go to 1.5. That would be right here. And we're at this graph, which this would be not 50, 60, 70 cents. Now, based on it, what would be the rate when we weigh 3 ounces, meaning x equals 3. Ooh, there's an open circle there, so I'm not going to count that, but let me go up to this. All right, and let's see what number that would be. This is 1.10 cents, and a little bit more would be 1.15 cents. We wouldn't be 1.20 because we didn't hit the next line yet. We're in between 1.10 and 1.20, so 1.15. Alrighty, let's look at this Regents question, this long response question. It says, the table below lists the total cost for parking for a period of time on a street in Albany, New York. The total cost is for any length of time up to and including the hours parked. For example, parking for up to and including 1 hour would cost $1.25. So even if you're parked for only 40 minutes, that's close to an hour, so you're going to pay $1.25. If you're parking for 3.5 hours, so almost 4 hours, you pay $5.75. So let's look at this. We want to graph it. At 0 hours parked, you're going to pay $0 because you didn't park for all. So that's a definite point. Now, anytime you pass the 0 hours, you're going to start paying for the 1 hour parked, which is $1.25. So at 0, once you're a little bit over 0, you're paying $1.25. So that's an open circle there because you're not always definitely paying the $1.25 because if you were exactly 0, you would be paying $0. Up until when you're hour 1, you're definitely paying $1.25. So that's a closed circle. Then from 1 hour parked up until 2 hours, you're paying $2.50. So at 1 hour, that's an open circle at $2.50 because if you were exactly 1 hour, you'd be paying $1.25. And then at 2 hours, you're exactly $2.50. So that's a closed circle. Then from 2 to 3 hours, you're paying $4. So at 2 hours, that's an open circle at 4. And then at 3 hours, you're definitely paying $4. So that's a closed circle. Now, from 3 hours to 4 hours, you're paying $5.75. So, I went a little bit too far with this yellow. I meant to only go to this point right here. Okay. So then, at 3 hours, when you're a little bit more than 3, you're paying $5.75. So I'm going to put an open circle there. But then definitely at 4 hours, you're paying $5.75. So that would be a closed circle. Then from 4 hours to 5 hours, you're paying $7.75, which would be right here, an open circle. But then at 5, you're definitely paying that. Is this 5? Yes. You're definitely paying that $7.75, so that's a closed circle. And then lastly, from 5 hours to 6 hours, you are paying $10. At 5 hours, you're paying $7.75, so that's why there's a closed circle there. But then a little bit over 5, you're paying $10, which is why we put an open circle there. And then at 6 hours, you're definitely paying $10, so that's a closed circle. There we go. And now they want us to explain how the cost per hour to park changes over a period of 6 hours. So let's think about it. As soon as you parked a minute over that whole number, so as soon as you're a few minutes over 1 hour, you are going to have to pay the next parking rate. So each hour your vehicle remains parked, your total cost increases by $1. This increases by $1.25. Then right here, we increased by $1.50. Here was $1.75. Here was $2, and this was $2.25. So we can say, each hour, the price increases by another 25 cents. From the original amount that it already went up. All right. Let's look at the next question. Multiple choice. Morgan can start wrestling at age 5 in Division 1. So at age 5, she is definitely Division 1, which means at 5 we want to have a closed circle at 1. So not number 2 and not number 4. Then he remains in that division until his next odd birthday. So at 7, he's going to go to his next division. So at 7, he's no longer going to be in this division, but now he's definitely going to be in the next division, which is answer choice 1. Answer choice 3 and 4 would never make any sense because it's saying at age 7 he's in 2 different divisions. I don't think so. Or it's saying here at age 7 he's in no division, so no. 3 and 4 would never make sense. And 2 doesn't make sense because at 7 is when he goes to the next division, so the closed circle should be at the higher division, which is why it is choice 1. Now let's start looking at piecewise functions. Piecewise functions are functions that have 2 or more rules split over different domains. So these are your domains. And then instead of just having a plain number like we did in a step function, we're actually going to have an actual function. For this lesson, we're going to have linear and absolute value functions. When you create a table of values, you should determine which function rule you are using, and then you'll have to decide if we're going to have open and closed circles, and we plug in that value of x to the function that we are given to find what our value of y is that we're going to graph. All right. So guided practice. Evaluate the following piecewise functions. Reference the appropriate interval and use the correct function. Okay. First, we are told that x equals -2. If x equals -2, that means x is less than 1. So we would be using the function 2x to the third minus 1. And we're going to plug in -2 there. So 2, our x is -2 to the third power minus 1. Our value would be -17. Okay, then when our number is 8, if we're 8, that means where x is greater than or equal to 5. So we're going to use the absolute value x minus 2. X is 8, so 8 minus 2 is 6, and the absolute value of 6 is just 6. Okay, now if x equals 5, that means we're not in between 1 and 5 because their 5 is not included, but we are greater than or equal to 5. So the absolute value of x minus 2. 5 minus 2 is 3, and the absolute value of 3 is just 3. All right. Now, when x equals 1, that means that x is not less than 1, because 1's not included, but we are in between 1 and 5 since 1 is included, and our answer is just 3. And now when x equals 3, that means we're in between 1 and 5, which the answer would just be 3. Alrighty, let's look at the next one. I want you to pause the video and try this one. Evaluate the following piecewise functions. Let's use the appropriate interval and the correct function. Okay, x equals -4. When x equals -4, that means where x is less than or equal to -2. So we're going to use the function 2x plus 8. Wherever we see that x, we're going to put in -4. Plus 8, we get 0. Okay, now when x equals 4, that means where x is greater than 3. So that's the square root of x plus 3. Well, 4 plus 3 is 7, so we would just have the square root of 7, which can't be simplified. Now, x is -2. If x is -2, that means we're not in between -2 and 3 because the -2 is not included, but we are x is less than or equal to -2. So 2x plus 8, wherever we see the x, we're going to replace it with -2. Plus 8, and we get 4. Now, when x equals 2, that means we're in between -2 and 3, so we would have x squared minus 3. 2 squared is 4, minus 3 is 1. And now, when x equals 3, that doesn't mean where x is greater than 3 because 3 is not equal to, but we are in between -2 and 3 since it's equal to 3. That would be x squared minus 3. 3 squared is 9, minus 3 is 6. All right, let's see how we will evaluate piecewise functions when we are given the graph. All right, first we are told that x equals -1. That means we go to the left 1, and our graph is right here. It would be 0. Now x equals 2. When x equals 2, we're right here, and that is, we went up 1. All right, when x is 1, we're right here at that closed circle, we went up 1. When x is -2, at -2, we're right here. There's 2 different points, but we use the closed circle point, which is down 1. And when x is 0, that means we don't go left or right. We're right here, and we went up 1. Good. All right, let's look at this next one. Pause the video and try this one. X is -4, which would be right here, and that is 0. X is 1. 1 means go to the right 1. We have these 2 points, but I only count my shaded in circle, which is up 1. All right, at 3. 3 is right here. Go to the right 3, and our point's already there, so that's 0. All right, x equals 2 would be right here. There's 2 points here, but I only care about my closed circle, which is down 1. And now at 1.5 means go somewhere like this, and let's go down to our graph. That is at -2. Good job. And that wraps up our lesson on evaluating piecewise functions, the graphs, and the actual written out function. And then we also learned how to graph step functions. Alrighty.